Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 6, Algebra of Points and One-Dimensional Coordinate Systems. Section 50, the Commutative Law for Multiplication. With the aid of assumption P, we will now derive, finally, the commutative law for multiplication. Theorem 6. The operation of multiplication is commutative, i.e., we have px times py equal to py times px for every pair of points px, py of L, for which these two products are defined. Assumptions A, E, and P. Proof. Let us place as before px times py equal to pxy and py times px equal to pyx. Then, by the first relation of Theorem 4 and interchanging the points px, py, we have p infinity, p0, p1, py is projective with p infinity, p0, px, pyx. And from the second relation of the same theorem, we have p infinity, p0, p1, py is projective with p infinity, p0, px, pxy. By Theorem 17, Chapter 4, this requires pyx equal to pxy. In view of the fact already noted that the fundamental theorem of projective geometry, Theorem 17, Chapter 4, is equivalent to assumption P, it follows, chiefly from Section 3, Volume 2, that Theorem 7, assumption P is necessary and sufficient for the commutative law for multiplication. Assumptions A and E. Footnote. The existence of algebras in which multiplication is not commutative is then sufficient to establish the fact that assumption P is independent of the previous assumptions A and E. For in order to construct a system, chiefly page 6, which satisfies assumptions A and E without satisfying assumption P, we need only construct an analytic geometry of 3 dimensions, as described in a later chapter, and use as basis a non-commutative number system, for instance, the system of quaternions. That the fundamental theorem of projective geometry is equivalent to the commutative law for multiplication was first established by Hilbert, who, in his Foundations of Geometry, showed that the commutative law is equivalent to the theorem of Pappus, Theorem 21 of Chapter 4. The latter is easily seen to be equivalent to the fundamental theorem.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.